Welcome, folks. Now, before I start this one, I'm going to put up a disclaimer. And the disclaimer isn't specifically for you guys. This presentation will probably end up being shared and available publicly. And whilst I know that the people that are on this meeting at the minute are grown up and responsible and know how to treat batteries and how to deal with batteries and how to deal with wiring, that's not always the case. And so I have to point out that lithium batteries are dangerous. They can be explosively dangerous. And so anything that happens to anybody here after they've seen this presentation isn't my problem. And it's not WOSAG's problem, and it's not MERG's problem. Now, I don't speak for WOSAG and I don't speak for MERG, but all of those organisations, including me, want nothing to do with anything that you do after you've watched this presentation. I've also added a wee thing there that I keep a tin box, an old shortbread box on near my bench. If anything goes bang, I can put it in the shortbread box while I carry it outside, or actually run screaming outside with it. Lithium batteries, it turns out that if you put them in a box and put a cover on it, it doesn't stop the fire. Slows it down but doesn't stop it. The recommended solution is excess water, i.e. drop it into a bowl of water. Now, if you want to do that, that's down to you. I haven't done that yet. Previously, at that URL there, we did a quick video on 18650 batteries. 18650 batteries are 65mm long, which is about, I don't know, 3.5 inches. And they're about 20mm across, 18mm across, and they're used extensively. They're a really good power source. But recently, a new source of small, powerful lithium batteries has emerged, and that's these things, disposable vapes. They're everywhere, right? Literally, those are just some off of the box of these things that I keep. They are litter. If you go out for a walk, you will see these things lying in the gutter. They're very, very popular with teens and young adults. So if you're anywhere near a secondary school or a public park, you will find these while you're out walking. Now, I don't live in the Lower East Side. I live at the back end of a wee seaside town in the west of Scotland. And I reckon I've got about 60 or 70 of these that I've picked up this year already. They're everywhere. And I'm picking them up initially because they're potentially dangerous things. I suspect that they're dangerous to people, and in a few years from now, there'll be a fairly major health crisis because of these kids and these things. But that's not why we're talking about, not what we're talking about today. They are, though, potentially dangerous to animals. They contain a lithium battery, which, as I've already said, can be an explosive thing. They contain nicotine, which can be deadly to animals. And the metal shell itself represents a hazard for animals. So they're not very nice things. They're also misusing these lithium batteries. Lithium batteries are rechargeable, and they're a rechargeable resource that is not particularly sustainable. There's only very limited supplies of lithium. And this is tons of lithium going straight to landfill. And I'm a great believer that actually, rather than going straight to landfill, if I can reuse some of it, that'll save the planet in a very small way. If you are going to pick up one of these that's litter, please be aware that it's got a history when you get to it. It may have been stamped on, it may have been run over by a car, it may be unsuitable, it may have to go in the bin, but there you are. Now, I already showed some pictures of them. So in order to deconstruct it, basically there's a black plug at the bottom. You give it a gentle twist, give it a pull, and pull all the innards out. As you pull the innards out, you'll find, well, I'll show you what you'll find. But if you remember the rule to only ever snip one wire at a time, you can pretend you're playing at unexploded bombs with these things, because technically that's what they are. If you put snips across two wires, you could cause a short circuit that could cause interesting things to happen in your afternoon. It's also worth keeping, as I say, a bowl of soapy water handy, because they're full of flavoured glycerin, which isn't particularly pleasant and needs to be cleaned up. And that bowl is also a good mitigant if things suddenly go south on you. So here's one, currently blue Raz lemonade flavoured. What Raz is, I have no wish to know. There's a pair of little water pump pliers. Everybody should have a tiny wee pair of water pump pliers, really useful tool. Just in front of the water pump pliers, you see the black plug that's at the bottom of this. I nearly said butt plug, it's not, it's at the butt end of the thing, and it's a black plastic plug. There's a little gap there. That little gap is where the air goes in and the light comes out. That's the vent for air going into this thing, and there's a little blue LED in there that shines when the air's going into it. If I grab the end plug with my water pump pliers or a pair of combination pliers and give it a slight twist, it's only in there under friction and it pulls out. As it pulls out, you see the battery starting to emerge, and all I have to do is just gently ease the stuff out. There's no screws, there's no fixings, there's nothing like that. And there's what I'm left with. The plug at the right-hand side, the three wires going from the plug, a couple of them go straight past the battery up to what I'm calling the hot end at the left-hand side. Pardon me. And in the middle, the battery. Now, looking more closely, there's the battery, there's the hot end, and there's the wiring. The battery itself is a 13400, 3.7 volts, just over half an ampere hour, 2 watt hours. So if you're drawing 5 milliamps off of that, it'll give you 100 hours easy, 110 hours maybe. The battery is the same diameter as a AA. It's about 2/3 the length of a AA. An 18650 battery is 18 millimeters in diameter and 665.0 millimeters long. This is a 13400 battery, so it's 13 millimeters in diameter and 40.0 millimeters long. That one, as you see, has got a couple of wires soldered to it, which I'm going to talk about in a wee minute. So it's about 2/3 the size of an AA, the same diameter. If it's an N gauge, it's the equivalent of a load that's 6 foot in diameter and 18 foot long. So that's not an unsensible thing to put in a wagon or put in a trailer or whatever. If you're in AA gauge, it's equivalent to being 3 foot in diameter and 9 foot long. So again, it's not unreasonable to think about that as being a potential load as well as being the battery for something. If you don't fancy your chances on the mean streets, you can buy these things. First of all, our friends in the East will £3.22 each, down from £5.20. Plus shipping, of course, at £2.61, takes that up to about £6 for a battery, down from about £8.50 for a battery, which is quite a lot, because the vapes themselves, you can buy 3 of those for a tenner in B&M. I was round there for something else through the week, and they're selling 3 of these things for a tenner. This one that we see from China is a 400 milliampere hour. I've never seen one of these. All the ones that I'm getting out of the thrown away ones are all 550, 600 milliampere hours. I suspect that they're getting bigger and getting better. Either that or the ones that are going into the vapes have been mislabeled, because, you know, it's coming out of China, you don't know what you're getting. Looking at the rest of the construction, the plug at the end has an air vent, as I say, and behind the air vent there's a little blue LED which is attached to a SIP switch. Now that SIP switch is an airflow switch, it's not a pressure switch. There's 2 ways you can detect air. You can detect the pressure going up or going down, or you can detect actual flow, and that one detects flow. If you made it a pressure switch, then they'd be unable to be transported in aircraft, And for that reason, they wouldn't be as popular as they are now. These things are getting flown all over the world for China. So it's an air flow switch that's in it. They get used in certain equipment for disabled people that can't use a mouse or a keyboard, for example. They use a SIP switch with their mouth as an input device. They're used for various other things in electromechanical and commercial uses. But I don't have a great use for them. And I've now got a box with dozens of them in it. And then there's the hot end. When I saw the hot end, I thought, great, I'm going to get a load of nickel chromium wire here, and I'm going to be able to make a battery-operated bending device for acrylic and stuff like that, because nichrome wire is quite expensive and quite hard to get a hold of. So, good, I'm going to take some interest in these hot ends. So I took that hot end and dismantled it. And there's what's inside it. The nickel chromium wire is that loop at the top. There's about 1 inch of nickel chromium wire in this, which isn't a hell of a lot of nickel chromium wire, at least not for my purposes. But if you want to make a puffer, if you want to make a steam generator for a model railway layout, then that tiny wee, whatever it is, 3 turns, 4 turns of nickel chromium wire and the heat-proof sleeving that's there might be useful for that. So let's move on to the battery and talk about the wiring. The thing is made of aluminium foil. I spoke elsewhere about how when cassettes and reel-to-reel tapes disappeared from the scene 30 years ago, the companies, Toshiba and Sony and Panasonic, that were making all that stuff suddenly started making batteries because it's the same construction. It's rolling a tape up really, really tight. And that's how these are made. They're just an aluminium foil with the material on, rolled up tight. And then a little tag for the aluminium sticks out either end to give you the lugs to solder on. You'll also see some brown Kapton tape. If you've not met Kapton tape, that's that brown polyamide tape that gets used quite a bit in the electronics industry. It's resistant to temperatures and it's resistant to solder, and it's great for masking off things when you're doing surface mount devices or when you're doing rework on electronics boards and stuff. So you'll find little bits of Kapton tape on here as well. The device itself will have solder on it. The solder that is on it will be solder for soldering to aluminium. Your normal solder really won't work with these boys. So I'm going to talk about that in a minute. And the wire that's in them is that cheap copper-coated aluminium wire that comes from China in great amounts. And it's horrible. And don't try to use it. It's got no current capacity and it hates getting soldered, and it really is not nice. If you do decide to solder onto one of these things, then I thoroughly recommend that you use a heatsink on the aluminium lug. That is to say, put a pair of radial pliers or a crocodile clip between where you're soldering and the battery. The lug sticks out maybe 10, 11 millimeters, so you can get a pair of radial pliers to hold the thing at one side and then you solder out at the extreme end of it. Let's have a look. There's one of them. You can see the brown Kapton tape. You can see the solderable lug that sticks out at the far end. And as I say, I thoroughly advise using a heatsink on these if you're going to have any success. Now, a pal of mine had a go with them, couldn't get on with them until I gave him a couple of meters of this aluminium solder. We talked about this on these meetings well over a year ago now. Davey went out and bought a roll of this and we were selling it in, I think, 2 meter lengths. It's only useful for aluminium, but you only need the tiniest drop of it. What you do is, if you've got an aluminium tag, like the end of a battery or something like that, you heat up your soldering iron, you melt this, that'll take to it, but you only put a tiny drop on, just enough to tin the surface. And once the surface is tinned, you can then put more solder on, but you put your normal 60-40 lead tin solder on, not this aluminium stuff. It's only used for the first tin surface, for the surface where the aluminium meets the solder, and then you put normal solder in. So you really don't need a lot of this, which is good because it's expensive. I looked it up this morning, and the Farnell, that purn of it, which is a ½ kilogram purn, is currently over £30, which is not something you need to buy. You only need a metre of it will do you for the rest of your life. If you get 2 meters, you can leave it to your family in your will, because you really don't use an awful lot of this stuff. And when you solder wires to it, if you just solder a wire to a battery, then what you leave is a couple of wires floating about. And if they touch each other, you've got a spark, you've got a bang, you've got heat, you've got dangerous things. So you really have to terminate the wires that you're putting on batteries. And recently I've done a lot of that with pH connectors. We've all used DuPonts, and we'll talk about them in a wee minute, but another emerging standard is the GST. GST stands for Japanese Solderless Terminals. That was the big company that introduced crimp connectors to Japan first, and then America, and then the world. And GST make hundreds of different flavors of GST connector. But the specific one, the GST pH connector, started being used by the people that do drones and the people that do radio-controlled aircraft and radio-controlled cars and stuff for connecting lithium polymer batteries. And it's become a standard whereby if you're putting a battery onto something, you use a pH version of the GST connector. So much so that they've now been picked up by the likes of Microchip and Adafruit, and they're starting to appear on equipment. They're outrageously expensive. 73p buys you 20 of them, plus the connectors to plug into them. And I have put in an aware here, a please be aware. There's a couple of things to please be aware here of. I bought 20 of these from our friends in the East, and then I forgot that I'd ordered them. And I ordered them again, and ended up with 2 batches of 20 of these from our friends in the East. I've spent £3 in these things, and I've got a box of the damn things. Every one of them that came to me had the wires in the wrong way around. Being a bit of a Boy Scout, I check everything. And so I checked that the plug fit so that the wires were the right way around. And it turned out that the one that went to the positive on my circuit was the black wire. The one that went to the negative was the red wire. So I had to rework them. Now, reworking them is really, really trivial. What you do is you get a pair of pliers and a rubber band. You use the rubber band to hold the pliers shut. You then open the pliers, squeeze the plug into the pliers, and let the pliers hold it steady to keep it from moving on your bench. A pin will simply lift the wee tongues that hold the wire. You lift the tongue, pull the wire out, lift the tongue, pull the wire out, put them back in the other way around, squeeze it with your finger, and that's you remade the connector. It takes about 30 seconds to do. It's trivial. But the other thing to remember, apart from checking if you buy these things, checking that you get the right ones, is to make sure you get the pH part right. There are BH and BL and BZ and all sorts of other different GST connectors. But if you're going to buy these ones, buy the pH ones. It's really important. So here's one of the current pieces. If you go to Microchip's website, this is one of their current development boards for something called the Curiosity Nano. It's a board that plugs in. It looks like an Arduino Nano, but they've got them for PICs, they've got them for STMs, they've got them for ARM chips, they've got them for Cortex, M0s, STMs, a whole lot. They're all there, and you can plug in any processor, and you can plug in basically any peripheral. It's a brilliant wee board. If you look at the top left, you'll notice the pH connector that my battery's plugged into there. See it? And next to the pH connector, there's a charging circuit. It turns out that if you get 5 volts on this Microchip board, because you've got it plugged into the USB, for example, then it charges the battery for you while it's doing whatever it's doing as well. So in there, I'm writing software for a DCC accessory decoder, but at the same time, I'm charging that battery, which I'm now going to use. If you're using DCC, then it might be that one of the wires coming out of your DCC controller is at earth potential. And if that is the case, and you start plugging something in, and it's got a power supply that's earthed, then you could end up with the two earths connected to the same piece of track, which is fine. But you could equally well end up with the two earths connected to different tracks, in which case you've got a short circuit and problems arise, mostly in power supplies. And so for that reason, very often, if you're working with a piece of equipment, it's a good idea to have it completely isolated. And a cheap and easy way of completely isolating it is to run it off a battery. There's another one. That's an ESP32 board. That's the new ESP32S3. And as you can see, that one's got a USB-C connector on it, and it's got a little OLED display, multicolor graphics display. That's quite an expensive thing. It comes in about £12, but it's much easier to write code for an ESP32 if you've got a display like that you can just pop answers out on. You can pop your debugging material out on. And again, there's the JST connector, and underneath it, there's the charging circuit. So that wee board will charge. When I'm using the USB, it will charge the battery, and when I'm not using the USB, the battery will power it. So that's why I'm kind of pushing the point of these PH connectors. JST for Japanese solderless terminal, PH for the flavour of connector. And then there's the point. We've all used the point connectors, they're everywhere. They're cheap and cheery, they plug into 0.1 inch, so they plug into Veriboard, they plug into printed circuit boards, they go anywhere. Always remember that you use, on the battery end, you don't put the pins, you put the socket. If you put the pins on the battery end, then when you put the battery down, you can short out the battery on a screwdriver or a pair of pliers or a screw that's lying about your bench. So for safety's sake, you always put the socket on the battery. There's one there. A couple of things to point out. That board is a standalone level crossing that I did years ago now. We were talking about a level crossing circuit as a pocket money kit. I don't think anything ever came of it. It still runs, and it runs off one of these little batteries. Also, if you notice, I use a 3-pin DuPont very often. Put the power in the middle and the ground at either side, and that way you can plug it in either way around. You're not likely to plug it in the wrong way around. It's a cheap trick, but it's one that's sometimes useful. So we've got the batteries, we've got them connected. Once we've used them, we have to charge them. And there's lots of ways of charging them, and there's one or two ways of not charging them. Do not, under any circumstances, plug one of these things into a USB socket. A USB will give you 5 volts. This thing's expecting between 2.7 and 4.2 volts. If you give it more than that, it'll draw too much current, it'll overheat, bad things will happen, and I will not be held responsible for those. Reference the disclaimer that I talked about at the top of the chat. What you can do is use a bench supply. Now, there's a video there that we made years ago on how to charge 18650s using a bench supply, and it's there. I recommend you go and have a wee look at it. It's on the WASAG website, and the same rules apply to charging these batteries using a bench supply. Or you can buy a specialist charging unit. I'll show you some of them in a minute. Extortionately expensive. Or you can buy a specialist charger chip. There are 4 or 5 different charging chipsets for these, and I'm going to talk about the charger chips at a wee bit of length in a minute. Or what you can do is buy a power bank and take the cell out the power bank and just use this instead of the cell in the power bank, and the power bank circuit will charge it. I'll show you how to do that as well. There's the chargers from AliExpress. £3.22 for a good one, £1.74 for a dodgy one. They're not a lot of money. And a lot of these things, if you look at the dodgy one on the left, it's got a mobile arm that goes up and down, so it'll fit various sizes of lithium cell, including this one. And you can just plug that in and plug a USB into it, and it's got the electronics in it to charge it. So that, if you were going to be charging these things regularly, might be a solution, and it doesn't involve getting the soldering iron out. But we're not here because we don't want to get the soldering iron out. So for that reason, I'm going to move briskly on. Here's a power bank that I got from the pound shop, and it cost me, I think it was £2 or £3. At the bottom, you can see the whole power bank as it came. And then moving up is the version of it where I clicked it open. There's a plastic box, there's a white plastic cover, and in between there's an 18650 cell and the little board with the USB socket on it for charging and the charger circuit chip, plus the support resistors and all that good stuff. The other side of that board has also got a USB outlet on it to let me use this to charge a USB device. And again, you can get those in the pound shop for £2 or £3, £3 or £4 maybe, and you get a free 18650 cell with it. Now, going on to the actual chips themselves, the most common power bank chip is one called a TP4056. And that provides a proper charging profile for a lithium polymer or a lithium-ion battery. That video that I showed you earlier discusses the charge profile. I'll go over it again in just a moment. This chip can take 8 volts maximum and can provide 1 amp maximum. Now, 8 volts means that you can drive it from USB. You can drive it from a power supply if you want to do that. You can also drive it from a photovoltaic cell. If you want to put one of these into a circuit and then put that circuit out in the garden to remotely monitor temperature or humidity or whatever, then you could put a PV on it, and this chip will use the PV to charge the battery and keep everything right. The other thing I've got to point out is if you're going to use USB, the most common place you're going to find a USB is either on a charger for your phone, which is fine, they can charge 1 amp or 2 amps, or a computer. But most computers, if you try and take more than 500 milliamps off a channel, will give you an error and stop charging. They won't supply more than 500 milliamps. You get a pop-up error on the screen and the charging will stop. So for that reason, you really want to limit your charge to less than 500 milliamps. Actually, I limit the charge to quite a bit less than 500 milliamps because I think that I can get more life out of batteries by charging them more gently. Moving on with this chip, from the data sheet, there's that profile. When you put electricity onto it, you set it at whatever the constant current is. In this case, they've set it to 1000 milliamps. And let's say you put a discharged battery in there, and the discharged battery is at 2.7 volts or something like that. Then what will happen is the constant current will kick in and it'll charge at 1000 milliamps. And as it charges at 1000 milliamps, the voltage will creep up and creep up and creep up until it gets to 4.2 volts. And when it gets to 4.2 volts, it'll stay at 4.2 volts, but the current will then tail off and tail off and tail off until it gets to 1/10 of the 1000 milliamps. So when it gets to 100 milliamps current at 4.2 volts, it says this battery is charged and it stops. And this wee chip does all of that for you. I'll move on to the circuit. There's the circuit diagram for the chip. You see the chip itself. There's two LEDs over to the left, one for when it's charging and one for when it's charged. The battery is over to the right. And apart from that, there's a couple of resistors. There's one called RProg, which is on pin 2 of the chip. And RProg determines how much current the chip charges at. Now, we're going to talk about getting these things pre-built on a module. And most of those modules come set to charge at 1000 milliamps, which is fine for an 18650, but a bit much for a rear battery. And you can change RProg, and that'll change how much current you charge at. So if I want to charge at 500 milliamps, I take it down to about 2.5K. You can see for the table there, milliamps on the right and how many K on the left. And by changing that resistor, I change the charging current. Now, before we go into the modules and how they work, there's another circuit I want to talk about, and that's called DWO1. DWO1 is a battery protection IC. It protects against overcharging, over-discharging, overcurrent, or over-voltage. It makes sure that if bad things try to happen to the battery, that they can't happen. There's the circuit of it. The chip itself, the battery, and two MOSFETs, M1 and M2. Now, if you find a DWO1, you'll find it like that. There's a battery out one of these vapes, and over to the left-hand side, you'll see a tiny wee printed circuit board with two little 6-pin chips on it. One of those 6-pin chips is a DWO1, and the other 6-pin chip is two MOSFETs to protect it, so that if I try to over-discharge that battery, that circuit protects it. If I try to overcharge it or overvolt it or whatever, that circuit protects that battery. You also get them on bigger batteries, 18650s. The battery at the front there is an 18650, but you can buy them like the one at the back, which is just slightly longer. And it's slightly longer because it's got a washer of printed circuit board WO1 on it to stop the battery getting over-discharged, shorted out, overcharged, or whatever. And if you've got 18650s like that, but they're not protected, you can buy these from China, a strip of 10 DWO1s with nickel strips on them. And you simply solder that across the battery. And as you solder that across the battery, that does the protection for the battery to stop it, bad things happening to it. So the DWO1 is really important. It's really useful. And when I show you the prices, you'll explain why I'm saying you really need DWO1s. You can buy a module that's got a DWO1 along with the TP4056, and they're extremely cheap. You can buy 10 of these things for the same price as buying one. Keep an eye on the postage. Amazon will get it to you tomorrow, but it'll cost you a wee bit more. And the other thing you have to remember is that, you know, if you're charging these things from USB, you'll have a cable already that plugs into your wall charger or your phone charger or your computer or whatever, and it'll have a mini USB or a micro USB or a USB-C or whatever on it. It's worth buying the one for the cable that you've got. It's not worth buying these things for pennies and then having to spend money on a cable because you bought the one with the wrong plug in the end of it. So please bear that in mind. And the wee module will also charge from a DC source, or as I say, a photovoltaic cell if you want to do it outdoors. Let's talk about the prices. That is for 10 of those. 10 of the modules with the TP4056 on at 92 pence. So that's 9 pence for a module. You can't buy that USB socket for 9 pence from any of the usual suppliers in the UK. So it's really worth buying these modules. It's not worth buying these chips and building these boards at that sort of price. However, that one has got well, it's got the TP4056 on it. It doesn't have the DW01 on it. That one does. £2.69 for 10 of them. So 26 pence buys you one of these. £2.69 buys you 10 of them. And that one's with free shipping. So your £2.69 includes shipping for 10 of them. So they're 20 pence each. And if you look closely, that one's got a USB-C connector on it. It's also got the DW01 chip on it, and it's got the MOSFETs on it. So that's the whole lot, the whole 9 yards for 26p, including shipping. If you want to go to Amazon, you can have it tomorrow. There's a 10-pack for £4.99. So that's 50p each. If you want, if you've got money to slash about, then you can have 50 pence you can spend on these. Again, that's a good picture of the board. It's got the 4056 behind the socket. That one, notice, has got a micro USB on it. See what I said about sometimes you get micro USB, sometimes you get USB-C. Make sure you order the one that you've got the connectors for. You can also see that next to the USB socket are the plus and minus wires if you want to solder a photovoltaic cell on there, or you want to solder a barrel jack or something for connecting power to it. But remember, no more than 8 volts. The 2 LEDs are at the top of the board, and then you see the DW01 chip and the 2 MOSFETs, and then 2 sets of outputs to the battery. And you also see R3. You see R3 at the bottom of the board there. That's the one that you change to alter the current. We'll talk about that in just a second. So here they are, delivered from our friends in China. And that's pretty much that board that you just saw. The charging rate, as I say, is set by a resistor. And it's one of these tiny, it's R3 on there, and it's a tiny, it's an 0402 or an 0201. It's a really tiny SMD resistor. It's a bugger. And it's set for 1 amp. Now, 1 amp is okay-ish for an 18650. I'd actually charge an 18650 at half an amp, because that way I reckon that the more gently you charge these things, the longer they last. But it's a bit high for a 500 milliampere hour. It's what they call C when they're charging these things. That's what's called a 2C charge. 1 amp is twice the capacity, the 500 milliamps. So it's probably a bit fierce for a charge. And anyway, as I said, if you've got a USB in your computer, it can only supply 500 milliamps. So I'm going to have to change that resistor. I go back to this diagram and I see that it's RProg is connected to pin 2. And if I want to get down to about 200 milliamps, then 200 milliamps is between 130 milliamps and 250 milliamps. So it's going to be between 5K and 10K. So in order to do that, I'll locate the resistor. There it is. Let me just take a wee bit of sneakiness while we're here. The resistor is on pin 2, and it goes between pin 2 and ground. But ground on that chip is also pin 3. Yep. So let's look. There's the resistor. If I'm a hot shot and I've got the equipment and I've got a hot plate and I've got hot air and all that good stuff, I could replace that resistor. But actually, I don't have a resistor. I've got resistors that are the right size, the right resistance, but I don't have any resistors that are that small because I can't see them and I keep inhaling them. And it's no good. So I don't use them. So I keep them out of the house. They go up the hoover. You don't need resistors that size in your life. So what you do You do. What you do is you put a soldering iron on that, get it good and hot, and then wipe it off. And the solder takes the resistor and anything else off, and you're left with a gap where that resistor is. You then take an ordinary resistor, pin it, and connect it to pin 2 and pin 3. Now that's a 6.2k resistor, because that was the resistor that I could find that was between 5k and 10k. And that gives me 195 milliamps, which suits me fine for charging these batteries. You'll also notice that I've used a couple of bits of wire to solder it to a bit of Veriboard, because that way I can solder my pH connector to the Veriboard. Because most of these that I've got lying about have now got the pH connectors on them that I mentioned earlier when I was talking about wiring them. And now I can just plug the pH connector in there. But I also put a couple of flying leads with crock clips on, so that I can simply crock clip onto one of these batteries to charge it. Having done that, I plug in the USB, the charging light comes on, and know that there's a DWO1 in that circuit. So I know it can't get over voltage, it can't overcharge, it can't undercharge, it can't short out, it can do anything it likes, and the DWO1's there to protect it. So I can go and have my coffee, and I come back in half an hour, an hour's time, and the light has changed over. The red light has went off, the blue light has went on, the visualizer that I'm using to take these pictures is rubbish at white balance, and so the white balance in that picture is garbage compared to the white balance in that picture. But it doesn't matter, it's a different LED, so you can see that it's charged. And once it's charged, that battery's fit to go. So let's talk about these batteries again. They are nominally 3.7 volts. That means that they're actually about 3.6 to 4.2 volts working range. Once they get down to 3.6 volts, they're starting to discharge really hard, and it's time to charge them again. They will operate down to about 2.6. The charging circuit will operate on a battery that's at 2.6, 2.7 volts. When I've been rescuing these vapes off the street, I've had them from 2.6 volts up to 4.2 volts. That's basically a fully charged battery. That's unusual. Usually they're at about 3.6 volts. They're a decent power, they're a decent wattage. They'll happily do 5 amps if you need 5 amps. As I've just explained, they need a slightly specialist charge, but that's fine. Don't discharge. If you charge it and disconnect it, it'll sit there for weeks. You know how nickel cadmium batteries used to have memories and things, and you had to watch how you charge them and discharge them and keep charging them even though you weren't using them. Not so with these boys. They're really good for that. One of these will just replace 2 or 3 AA's or AAA's. Because it's 4 volts, it's like 2 AA's or AAA's is 3 point something volts. 3 AA's or AAA's is 4.5 volts. So depending on your application, you can use one of these to replace the normal throwaway alkaline batteries. So we're saving the planet that way as well. And you can stack them. If you want to make a 12 volt supply, you can click 3 of these in series, solder them together, clip them together, whatever you fancy, and get higher voltages for making power supplies and making plus and minus supplies and stuff like that. It'll do it all. Now, without talking about modular railways, they're ideal for home and garden LED lights. They're used for home and garden LED lights commercially. If you've got something remote that you want to operate by Wi-Fi or Bluetooth, these are great for that, particularly things that don't take much energy and come up. I've got a pond, for example, and a little web server in the pond will tell me the DH and pH and turbidity and temperatures and all that good stuff. And it only comes up and does the measurement twice an hour. One of these will run that beautifully. If you want an on-earth supply, as I say, for testing equipment that's liable to be connected to an earth control unit or an earth something, and you want to float your supply, these are great for that as well. Mechano models, I was thinking very specifically about Brendan when I was doing this. And then all the other things, Arduinos and Raspberry Pis and the wee light soldering irons and Dremels. Put 3 of these and it'll turn your 12-volt Dremel into a mobile Dremel for going away over to the back of the layout or going underneath the layout with. You can operate your Dremel on 3 of these. No bother at all. You can even put a half a dozen of them together and use it to spot weld tungsten strips or nickel strips onto other batteries, although they won't last very long doing that. Mouses, keyboards, endless. Moving on to model railway uses. There's more than enough to do traction. These things will supply an amp for a couple of hours and not complain about it. N gauge, double O gauge, no bother at all. Autonomous traction. How about an N gauge loco that's pulling a wagon, but the wagon's got the battery in it and the electronics in it, and has got pickups on the axles, but the pickups aren't picking up, they're putting down. And so this thing drives itself based on the power pack, and it's effectively a tender, if you like. And you could put that on top of you could run it on a piece of track on glass or on acrylic, just for show-off's sake, with no visible means of support. My wife says that I've got no visible means of support, but we're not going to get into that at the minute. Secondary traction, your main layout's running on DC or DCC, and you want to run a shuttle, a standalone shuttle, or a tram, or a bus on a separate track, or a wagon on a pit underneath your layout. This will do all that for you without you having to worry about that, a secondary supply for it. On board, your layout, coach lighting's very obvious. If you want to put a firebox or an effect on a loco or on a wagon or on a brake car or something, ideal for it. By remote electronics, I mean remote from where your wiring is. If you've got a corner of your layout, put a signal or a station announcer or an animation out there, but you don't want to run wires to it, then you can just use this for that. And also mobile electronics, make a diorama of 4 guys with a digger doing trackside work. Power it off one of these boys, and you can then pick it up and move it to a different part of the layout so that they're working in a different part of the layout 1 week for the next, without having to rewire the layout to make that happen. Same way if you want to put a road accident or road works on your layout, you could use this small, light, long-lasting power supply to make that sort of stuff happen all over the place. Any thoughts, any questions?